Hi ladies, this is lesson 2.4 and this is about writing equations of lines. So we've already used the slope-intercept and the standard form, but in this lesson we work with what's called the point-slope form. And the point-slope form is if you're given the slope and you're given 1 point, then you can write it in the form y minus y1 equals the slope times x minus x1. So again, this is if you are given the slope and a point. So you'll see this in your textbook or on your guided notes. And again, what we're working with is here, given the slope and any 1 point, x1, y1, we can use point-slope form. And then eventually, if we wanted to, we can convert it back to slope-intercept form, because we could find the slope-intercept. So the first problem that you see on your guided sheets is to write an equation for the line shown. Well, in this equation, we're going to use slope-intercept form like we had in the past because we're given b, and by looking at the graph, we can find our slope. So use slope-intercept form. Well, we know y equals mx plus b, which in this case is 1. And to find our slope, we find some other point on our line and use our rise over run formula. So our rise in this case is negative, -1, -2, -3, and our run is +2. So our slope then is -3/2. And then our slope-intercept form is -3/2 x plus 1. But now if we're given an equation, if we're writing an equation for a line that passes through a specific point, and we're given its slope, we can write this in point-slope form. And point-slope form, again, is y minus y1 equals m times x minus x1. So here we're given the slope and a point. So y minus y1, which in this case is 1, equals the slope, which is 2, times x minus x1, which is 2. And now we can use algebra to solve for y equals. So y minus 1 equals 2x minus 4. Then we add 1 to both sides, so y equals 2x minus 3. So now if we want to write equations for parallel and perpendicular lines, and we know a point that they pass through, and we know the line, the equation of the line that they're parallel or perpendicular to, we can use point-slope form. So for parallel lines, we know that m equals -2 because the slope is -2 and lines that are parallel to this will have the same slope, and a line that's perpendicular to that line will have a slope of m equals the opposite reciprocal, which in this case is 1/2. So now we can use point-slope form with the given point, with the point that we're given here. So our point-slope form is y minus y1, which in this case is 1, equals our slope times x minus x1, which is -1, so it's x plus 1. Then again, we can use algebra now to solve. Y minus 1 equals -2x minus 2. Add 1 to both sides. And here's our equation of a line that's parallel. We can use the same procedure to find a line that's perpendicular. So y minus y1, which in this case again is 1, equals our slope, which is 1/2, times x minus x1, which in this case x1 is -1, so we're adding 1. And then we'll use algebra to solve. And add 1 to both sides. One and a half, or 3/2. Now, if you look at your sheets, and if you have the equation of a line, if you're writing an equation for a line and you have 2 points, well, the first thing you have to do is find the slope. Then you can use point-slope form. So if we have 2 lines, we're going to use the slope formula, which is m equals y2 minus y1 over x2 minus x1. So in this case, our slope is -3 minus 1 divided by 2 minus 3, which we get -4 over -1, which is 4. So now with our slope, we can choose either one of these points for point-slope form. So y minus y1, and I'll just go with this first point here, y minus y1 equals our slope, which is 4, times x minus x1, which is 3, and then I can solve for y. So on your own, try these next couple. I'm going to do the solution, so please pause the video while you work, and then to check your answers, you can unpause. So in this case, we know that b is -3, and we can find our slope by choosing any other point here. So our slope is rise 2 over run 3. Here we have our slope and we have a line, so we can use point slope form. And that's y minus y1 equals slope times x minus x1. Y minus 5 equals -2 times x minus 1. Here we need to know parallel and perpendicular. So parallel has the same slope. Perpendicular has the opposite reciprocal. And we can use point slope form. And then we can use algebra to solve for y. And then a line that's perpendicular has the opposite slope. We can still use the point slope form, but in this case our slope is -1/4. So we can use the same 1 point though. So y minus y1 equals our slope -1/4 times x minus x1, which is -2, so x plus 2. Y minus 3 equals -1/4 x minus 2/4, which is 1/2. And then we can solve for y by adding 3 to both sides. And then lastly, if we're given 2 points, we need to use this, find the slope first. So m equals y2 minus y1 over x2 minus x1. So -2 minus 2 over 3 minus 6. We get -4 over -3, which is the same as 4/3. Once we have our slope, then we can use point slope form, and we can pick either one of these points. Again, I usually just use the first one, but it really does not matter which one you use. So y minus y1 equals our slope times x minus x1. And minus 24 over 3, which is the same as 8. So y minus 2 equals 4 thirds x minus 8. Add 2 to both sides. And we get it back in point-slope form. Slope-intercept form. All right, the last one, try this one on your own. So please pause the video while you work, and then unpause for the solution. So for this one, I would start just by drawing a graph, just so you can visualize. This is 1993. This is 2003. This is where we started at 2 million 2 million females in high school sports in the US. And then by 2003, it went up to 2.86 million. So for this one, we're going to look at our change in y and our change in x. So here, this is our rise, and this is our run. So our rise is the difference between now, 2.86 million, and 2 million. Which is 0.86 million more females in high school sports. And our run is from 1993 to 2003, which is 10 years. So our rise over run, or our rate of change, is 0.86 divided by 10, which is 0.086. And what we started with, so this is our slope, and what we started with, our y-intercept, was 2 million. So an equation for a linear equation that models female sports participation is our y, our dependent variable. That's how many girls are participating in high school sports. And x is our years since 1993. So our y equals our slope, 0.086x, plus our b, our y-intercept, which is what we started with, 2 million. And we're just going to put this in, leave this in millions. So y in millions. And x is years since 1993. So if you plug in any year, 2017 for example, is 24 years since 1993, you can see how many, if this were linear, if this model actually was linear, you could see how many females were participating in high school sports in the US today. All right, please jot down any questions that you have and bring those to class, and we will go through those when I see you next. Thanks, girls.